How are we all doing, everybody? In this video, we are going to be looking at special right triangles, 45, 45, 90, and 30, 60, 90 triangles. And the reason we're looking at these two specific right triangles, you might be asking, what makes these special? Well, their side lengths have a ratio that will always satisfy the Pythagorean theorem, and those ratios help us solve these problems and also will be helpful in future courses. Okay, so the first one is a 45, 45, 90 triangle. So you see two angles that are both 45. So their sides opposite will be congruent. So this is an isosceles triangle. All right, and the ratio of the sides is that if both of my legs are x, then the hypotenuse will be x square roots of 2. Okay, so the 45 and the 90, so the two 45-degree angles, the sides that are opposite them, both are x, and the side opposite the 90, or the hypotenuse, is x square roots of 2. Okay, so setting up this chart can help. I also sometimes like to think, okay, if I'm starting here and I'm moving this way, I'm going to multiply by the square root of 2. If I'm starting at the hypotenuse side and working backwards to the legs, I'm going to divide by the square root of 2. Okay? And the other type of triangle is a 30, 60, 90 triangle. Now, the 30-degree angle is going to be opposite the short side. 60-degree angle is going to be opposite the medium side. And then the 90 is obviously going to be opposite the long side, which is the hypotenuse. And the ratio of the side lengths here is that the side across from 30 is x. The side across from 60 is x square roots of 3, and the side opposite 90, or the hypotenuse, is 2x. So if I were to set up a little chart here, I got a 30, 60, 90. Side opposite 30 is x. Side opposite 60 is x rad 3. Side opposite 90 is 2x. So what I always like to do when I'm dealing with a 30, 60, 90 triangle, because it's a little bit more difficult than the 45, 45, 90, is I like to call this side, the x, my home base. All right, if we can figure out what the x is, we can easily figure out what the side opposite 60 and the hypotenuse is. Because if I start at x and I'm going this way, all I need to do is multiply by the square root of 3. Or if I'm starting at x and I need to go to the hypotenuse, I'm just going to multiply by 2. All right, so that's if we have our quote-unquote home base, that x across from 30. If we've got another side length, I always want to find that x. I always want to go to home base. So if I started at the hypotenuse and I worked backwards to get to my home base, I would divide by 2. Because 2x, to go from 2x to x, I would divide by 2. And then if I had the side across from 60 and I needed to go back to home base, I would divide by the square root of 3. Okay? I don't, and we'll see in a couple problems, I don't necessarily want to go from 2x to x square roots of 3, because there's a lot of stuff to make 2x become x square roots of 3. I got to divide by 2, then multiply by the square root of 3. So instead of doing that all at once, I go back to home base. So always with 30, 60, 90s, try to figure out what is that x. I guess with both triangles, you can think that. Try to figure out what that x side length is, because then your calculations are going to be easier as you're going to the other side lengths. Okay, so these two diagrams, the 45, 45, 90, x square roots of 2, and the 30, 60, 90, x square roots of 3, and 2x, make sure you memorize those diagrams and understand how they work. Okay, because we can use those facts in order to solve for unknown lengths, which we're going to do in example 1. All right, so in example 1a, always identify what type of triangle you have. Well, this is a 45, 45, 90 triangle. So this x, or this 6, is acting as x. Okay, 45, 45, we got x square roots of 2. And this 6 here is acting as x. So this side opposite the 45 is going to be 6 as well. And your hypotenuse is going to be 6 square roots of 2. Zoom. Because if I go from 6 to this side, I'm going to multiply by the square roots of 2. Okay, so a couple different ways you can think about it. You can use my arrows, or you can kind of set up this table to identify the parts that you have. Okay, and part B, we've got a 30, 60, 90 triangle there. So if I set up a table, I know that goes x, x square roots of 3, and 2x. And x is currently 4, because 4 is opposite the 30, which makes the side opposite 60 4 square roots of 3, which makes the side opposite 90 8, because it's 2 times 4. All right, so if I were to use the arrows there, I would say, okay, to go here, I would multiply by the square root of 3. To go to the hypotenuse, I would multiply by 2. So there are the missing side lengths, 4 rad 3 and 8. So A and B, those are kind of your simpler problems where I give you x. What if we look at C and D now? Here in C and D, I don't necessarily give you that home base, that plain old x. So in C, you see that these side lengths are both x and x, which makes this a 45, 45, 90 triangle. So if I set up my table, I've got x, x, x square roots of 2. Well, this 9 square roots of 6 is currently playing the hypotenuse, which is x square roots of 2, which means that these two things are equal. 9 square roots of 6 equals x square roots of 2. So how would I solve this? How would I get the x by itself, that plain old x? Well, I could divide by the square root of 2. So then I got x by itself here. If I look and isolate just at this radical, I've got a 9 on the outside, and then square root of 6 divided by square root of 2. Well, 6 and 2 are both under the radicals, so 6 divided by 2 is 3, so there's a 3 stuck underneath the radical. All right, so x is 9 square roots of 3. Oops, I guess I already kind of had that. I don't need to rewrite it, right? So x equals 9 square roots of 3. That's how we can use the table to set up to solve for that plain old x. All right, if you wanted to look at the arrows, I have the hypotenuse and I'm going backwards to x. So I'm going to divide by the square root of 2, and then I end up doing the same exact thing. So set up your table, or start to just recognize the pattern of a 45, 45, 90, or in part D, a 30, 60, 90. So let's look at part D. So we've got this 30-degree angle here. So if I set up my table, I've got x, x square roots of 3, and 2x. And x is currently 5 square roots of 3. So if I'm going to the side opposite 60, I need to multiply by the square root of 3. So the side opposite 60, I'm going to multiply by the square root of 3. So I've got 5 square roots of 3 times the square root of 3. Those are bad threes. Let me try that again. 3 and 3. Well, square root of 3 times square root of 3 is the square root of 9. So I've got 5 square roots of 9, which is going to be 5 times 3, which is 15. So I get V here equals 15. So now I need to solve for W. W is my hypotenuse. So if I use my table, if I got to go from x to 2x, I'm going to multiply by 2. So 5 square roots of 3 times 2, that'll be 10 square roots of 3. Or if I'm starting at this side length, this home base, and I'm going to W, I'm going to multiply by 2. Same thing. 5 square roots of 3 times 2. It's going to give me 10 square roots of 3. So W equals 10 square roots of 3. All right, so that's kind of how you can use 45, 45, 90 and 30, 60, 90 to solve for missing side lengths. You don't need 2 of the side lengths in order to use the Pythagorean theorem if you've got one of these special right triangles. You can use this relationship between the sides. X squared to 2 for 45, 45, 90, and x squared to 3, 2x for 30, 60, 90. You can use those relationships in order to solve for missing side lengths. Okay, so that is some worked out examples. Make sure you study this diagram. And I'm going to scroll down because I've got 3 you try nows. Let's see if I can scroll out so you can see all 3 of them at the same time. Yep. So I got 3 you try nows there. They're probably going to be a little bit more difficult. So make sure you try those. We will go over them in class. Have a great rest of your day. I'll see you when I see you.